Hello, good afternoon, and welcome, everybody. My name is Gabriele Quattrocchi. I work for the coordination team of the StandICT.eu project. And today I'm going to be the moderator of this webinar. I'm going to fill my colleague shoes, Maria Giuffrida, the project lead of StandICT, who unfortunately couldn't be here today. As you know, we are going to put under the spotlight today the recently released report on the landscape and gap analysis around the standards in the semiconductor and chip technologies, which was supported by three projects, three EU-funded projects, ICOS, ALLPROS, and StandICT. Today, there are many of you coming from different countries. So up to this morning, we had 67 registrants coming mainly from Germany, Belgium, United Kingdom, but also the United States and France. And as you can see, the attendees represent the whole spectrum of stakeholders involved in the industry. So I believe that it's time now to present a really dense agenda. We are going to have several speakers who have been involved in the development of the report. So we are going to have Thomas Reibe, senior expert at the European Commission, DG Connect, Ryoichi Ishihara, professor at the Quantum Integration Technology Group of the Delft University of Technology, and also lead chair of the technical working group releasing the report. He represents the ICOS project. We also have Abhishek Ramanujan, co-chair of the technical working group and convener of the working group within the International Electrotechnical Commission that develops standards for the electromagnetic compatibility of integrated circuits. We also have Salahuddin Noor, co-chair and professor at the Quantum and Computing Engineering Department of the Delft University of Technology, Delft University of Technology, and he also represents ICOS project. And at the end of the round of presentations, we are going to also host Karim Tobic, Director of Cybersecurity and Technology Consultancy, co-chair of the Technical Working Group and member of two subcommittees of the Joint Technical Committee of ISO and IEC, working on cybersecurity, IoT, and digital twins standards. So before we turn over to the speakers, a few housekeeping rules. So the event will be recorded and the recording will be made available on the StandICT website afterwards. I would warmly ask you to use the dedicated Q&A box to pose your questions to the speakers. We will make sure to address them at the end of the webinar or during the presentations. You can follow the chat to be informed on the links and resources that will be published on the chat. And I will also invite you to share with us your comments and feedback on the recently published report. Any kind of feedback is welcome to improve the next version of it. So without any further ado, I would leave the floor to Thomas Reibe, who is going to set the scene of this event. Thank you, Thomas. Over to you.
Thank you, Gabriele, and thanks for the nice introductions. And it's my pleasure here to welcome you. So you would be interested to know why the Commission actually has asked here the 3 projects to develop the standardization landscape and doing some analysis about that. So overall, the semiconductors are a strategic core of our modern advancements and serving as a fundamental building blocks for everything from consumer electronics to complex industrial systems. As we stand on the brink of an area defined by artificial intelligence and hyperconnectivity, the role of standardization framework in the semiconductor industry becomes critical important. So this landscape analysis focus on almost 5,000 identified semiconductor standards and technical specifications, which are pivotal to driving the industry ability to meet global challenges. And we are really surprised to find up to 5,000 standards here. The standards and technical specifications in the semiconductor sector supports the industry by ensuring interoperability, increased reliability, and enhanced security across a wide range of applications. They provide the foundations of innovations while maintaining high-quality benchmarks that are covered for safe and efficient technologies deployment. In the context of semiconductors, these standards facilitate international collaborations, trade, and allow components to be seamlessly integrated in the complex and global supply chain. If we're looking here now in more in the analysis, from our side, we are really interested in certain aspects. For example, standards can help clearly define the use of licensing of standard essential patents, reducing barriers to trade by ensuring the critical technologies are accessible under fair, reasonable, and non-discriminatory terms. Also, standards establish globally recognized interoperability frameworks and facilitate, in that sense, also trade by ensuring that products work seamlessly across the borders. Also, standards minimize technical trade barriers and enable market access across borders by harmonized technical specifications and requirements, especially if legal requirements are different in different states. Standards are setting also uniform criteria for products and service performance, fostering competition based on quality and innovation rather than discrete specifications. So additional standards as semiconductor, it's a wide area of a really, very large value chain. A chip basically is going over 60 or more borders over his lifetime. So supply chain standards can harmonize the supply chain practices and can enhance cooperations among suppliers, manufacturers, and distributors among the different processes and reduce inefficiencies. So then standards also on emerging technologies ensure that these technologies like quantum computing, biotechnology, and AI are safe and reliable and ethical. And also from our side, standards help here to comply with legal requirements effectively and efficiently. The last big part, which is for us quite important, is that standard supports sustainability and addressing best practices on ecological way and across industries and might protect the environment. But also standards provide assurance to the consumers regarding safety, reliability, quality of the products and services. So in summary, standards are a vital tool to eliminate barriers and sensitive informations, enhance collaborations, and guide future research in various domains, which this analysis is actually focusing forward. So this gives a little bit my introductions, and I give it now the word to Ryoji.
Yeah, thank you, Thomas. Hi, everyone. So this is Ryoji Shihara from TU Delft. I'm gonna explain about methodology we have done during the standardization study. So what we have done first is we identified that ICOS is not enough to analyze standardization in semiconductors and chips. So we first formed a technical working group. And second, we identified standard development organizations, SDOs, and respective working groups. And third, we made classifications of types of modules, components, which is devices, and process steps and applications. And then we collected, as Thomas said, 5,000 standards, and we classified those into types of those classifications one by one. And then we analyzed statistics and then identified the gap, also the map, the gaps. So let me explain one by one. So first about technical working group, as Gabriel already mentioned, ICOS, which is the European project to propose international collaboration between Europe to the other country, and we make recommendation to EU. And StandICT.eu has a track record of standardization analysis. So we teamed up. And then ALLPROS.eu, also European project, has huge network with industry, also became part of it. Also, ICOS is a European organization of semiconductor industry. So they have also a huge network of companies in Europe. So we made then core team, as Gabriel mentioned, me and Sarahudin and Abhishek and Karim. We are the core members. And at the end, we will show the rest of members and we will acknowledge them. We identified SDOs. This is the one of SDOs. Those are international body. So most famous is ISO and maybe IEC. Those are SDOs that are international body. And then the next is also international, but based in USA, about semiconductor standardization. The most important is, of course, IEEE and SEMI, and perhaps JEDEC. And then we found out SDOs from USA, that is Heterogeneous System Architecture Foundation, and AEC. And last is SDOs from EU. And those are, let's say, big SDOs. We have small SDOs, but these are large SDOs. And next, we made classification of applications. And we map applications into this. First is consumer, electronics, is covered by these SDOs. Note that it's not accurate. Some SDOs also covers consumer, but it's difficult to plot this. Approximately, these SDOs are covering this consumer. Similarly for healthcare, industry application, automotive, aerospace and defense, overlapping with automotive, and security is addressed many SDOs, data center, and edge and cloud computing. And the last is, of course, as a nature of semiconductor, generic or transversal applications. Most of the SDOs covers this application. And then next classification is process steps. So semiconductor starts with design, with IC design block, and then IC design whole IC, supported by IC design EDA, tools, and services. And then the fabrication starts with materials, and then first front-end process, making patterns and lithography, etching. And then these are supported by front-end equipment and services. And then it goes to back-end process, dicing, packaging, distributing, testing and distributing. These are back-end process, and those are supported by back-end equipment and services. So those are the classifications for standards. And then we added emerging process technologies, such as advanced lithography, chiplets, advanced packaging, energy efficiency, and sustainability. Those are the emerging technologies. And some of those process steps classification has sub-classification of those emerging process technologies, such as, for example, advanced lithography in the front-end equipment service is the EUV step up, for example. Chiplet advanced packaging in back-end equipment service is pick and place equipment. Energy efficiency and sustainability in front-end process. This is then how to reduce energy or CO2 during front-end process. So those are examples. Next is a classification about module component technologies. So from the top, sub-5 nanometer process, photonics, quantum computing, neuromorphic ReRAM AI chip, and AI applications, edge and cloud computing, wide bandgap semiconductor chip, flexible hybrid electronics, MEMS, and generic use. So first 9 classifications are emerging devices. Next is relevance. Okay, so how those standardization are relevant to emerging technologies in semiconductor and chip, from very high to very low. For example, solar cells are classified in low or very low relevance in this study. Okay, I will show one example. Sorry. And then we list 5,000 standards, and then we classified on to this classification. So you will end up with some coordinates in this table of process technologies and devices and modules. So I will show you one example, and this is from IEC with this number of reference. The title is Neuromorphic Devices and how to characterize in-memory devices. And in this case, there's no abstract, but there's a link. You can check the content. And then this is, by the way, ongoing standards. It will be published in 2026, next year. And then we analyzed and we classified, okay, this is generic or transversal application. And this is the module of neuromorphic ReRAM. And this is, since this is characterization, this is backend, equipment for backend and service. So I just show you the way how we analyzed standards one by one. Okay, and then we're gonna show you the analysis results. So then I hand over to Abhishek.
Yeah, thank you so much, Ryoshi. So let me first start off again, thanking you all for the opportunity here. And my name is Abhishek Ramanujan. I am principal engineer managing EMC and applications in analog devices in Ireland. And of course, I'm wearing the hat of the IEC today. I'm the convener of the WG9 group with the IEC TC47 SC47A subgroup. So let's look into this analysis and gap, as you said, right? I think he made my job a little easier, showcasing how the generic and transversal applications actually dominated quite a bit. We can move to the next slide, Gabriel, if you can. Yeah, thank you. So on the application side, right, something that stood out. So what we did, of course, as Rich mentioned, we did an extensive review of several thousand publications, so it wasn't easy. And we systematically characterized every document as much as possible through the respective application domains to find out a distinctive trend, which may not surprise many of us, but the trend, what we found out was a majority of these standards were formulated to support generic, cross-domain or transversal, however you want to call it, enabling a single semiconductor device to be deployed across multiple sectors. Right? This is not new. This is something we have been doing for many, many years, and this is how the market has been organized for several decades in the semiconductor industry. So for instance, an example of this could be a microcontroller or an Ethernet transceiver, right? That we use commonly in automotive, industrial, consumer, but it's the same product. And although we know that the end application is different, the governing standards for the device architecture, the functional evaluation, the test, validation, and all that, including electromagnetic compatibility compliance, often remain consistent for the IC across these domains. Right? So although the system standards could be different from a semiconductor perspective, a lot of these things are common. So while this prevalence of generic transversal applications dominating, 2,000, 2,500 standards here, dominating the whole statement here, it's not a problem, because this is important, because we could then evolve these generic applications or fine-tune this application into smaller applications like, say, automotive specific or security specific and so on. Okay, so when we started looking into this in a bit more detail, we found out that, okay, take out the generic part, and there is something more that's present. And that part is that there are 600 plus standards that are tailored in the security domain, which is good, which is an upcoming domain, while other sectors such as automotive, industrial, consumer, healthcare also benefit from a degree of domain-specific standardization, albeit relatively with a very limited coverage. So in contrast, I think that this is what we are really interested to cover here, is there is a significant gap in the standardization framework that covers the emerging application areas such as data center applications and edge and cloud computing environments. This is what we will go in detail as we go into the next slides. So in the data center side, there were a few things that stood out. Okay, so first is, of course, the computational performance and how this is achieved. So today, the computational performance is primarily achieved through the reuse of established semiconductor technologies. Yet again, goes back to how the generic products could be reused, right? A lot of these things is usually done using techniques like multi-threading, load balancing, and sometimes you might have even read a lot of articles about vertical scaling, horizontal scaling, and so on. So it's usually, yeah, it's kind of building up from what we have and slowly evolving the capability of the system. But having said that, there are a lot of constraints imposed by the energy efficiency and sustainability standards in Europe and in the world. So current scaling mechanisms may start to introduce a lot of strain on the environment, right? And we should also be cognizant of the fact that the current strategy to expand data centers or edge and cloud computing infrastructure to meet the AI demands, right, the artificial demands that we have across the world, it needs a lot of physical resources. So physical resources here means land, facilities, supporting structures, which of course, needless to say, is only going to worsen the environmental impact, right? So this is a gap where we don't have enough standards to cover these gaps, to cover these problems. And then as we go to the next gap that kind of surrounds this is, here, go step back. Yeah. In the IC design phase, it's also similar, like how Ryochi presented a few minutes ago, right? There is a flow, right? Starting from design to manufacturing to testing to delivering the part. So another shortcoming that we noticed was in the IC design area, where current semiconductor design workflows are predominantly depend on proprietary EDA tools, right? And there is very little open source framework or standardized pipeline spanning from design through fabrication. So unfortunately, current trends may start to hit a roadblock as we tend towards heterogeneous integration and the chiplet-based architectures, for which the good practice would be to have standardized design environments so that it is easy to reuse existing IPs or even new IPs, but shared between participants, shared between vendors. And this is more and more important as we start developing security-based applications or security-sensitive components, yet again, bringing this whole AI into the current scheme of things, right? And again, from the beginning, we have been talking about this quite a bit. It's all about what can we do, make design or make a particular integration in such a way that it facilitates interoperability across vendors and platforms, right? This is a very important fact. So this, of course, which means that we need to start recommending a few ideas to the EU, and that brings us to the recommendations part, wherein we have the first recommendation that is based on what we saw. Next slide. The first recommendation from the gaps that we saw in the data center side. So our analysis showcased that the EU should spearhead initiatives aimed at advancing semiconductor technologies specifically optimized for data center, edge, and cloud computing applications. So these efforts should prioritize energy efficient architectures and keep scalability in mind from the get-go. So emerging materials such as GaN, you might have heard about it, gallium nitride, and others hold significant promise in this domain for high performance, low power solutions that align with next generation digital and environmental objectives. And coming to the design side, our recommendation to the EU is the EU should proactively position itself to influence and benefit from emerging standards in the chiplet-based semiconductor design. This effort would require the establishment of an open architecture framework for chip design, something that the automotive people talk about AUTOSAR, the automotive system architecture, something like that. But we need an open framework so that we can promote modularity, interoperability, and vendor-neutral integration. So leveraging existing standards such as IPxACT for IP metadata and UCIe for the chiplet interconnects are some examples of how this could be done, right? Complementary to this, our recommendation to the EU is to invest more in dedicated labs to validate, test, and certify chiplet architectures, primarily for security critical applications, ensuring trust and compliance across our ecosystem. So with this, I will pass it on to Ryochi and Salahuddin to continue for the next part of the analysis.
Yeah, thank you. So we will show you analysis on based on module components and process technologies. Can Gabriel click to the next page? Yeah, thank you. So we're gonna show you about results based on the module components and process technologies. Next slide, please. Yeah. Maybe, yeah, Sarafini, you can start.
Yeah, so this is based on analysis based on modules. So as Ryoichi already mentioned that we categorized or classified the emerging devices into 9 categories. And if you look from when we analyze the 5,000, almost 5,000 standards, if you look at the graph, we found that, okay, there are like mostly there are a lot of standards, but mostly used as a non-specific, and especially when we come to the emerging devices or classes such as sub 5 nanometer logic or quantum technologies or neuromorphic devices, there is no coverage or almost no coverage. Next slide, please. Gabriel, can you click to the next? Yeah, can you keep clicking? And then we remove the non-specific from the graph, and to show that how like small the the standards or work has been done in these specific categories. As we know, this sub-nanometer quantum neuromorphic, they're kind of the like next generation computing or communication, AI, 6G, whatever you mentioned, they're kind of the powerhouse, they're kind of the next going to be engines. And if you look at this, the standards, like it's less than 0.1%, 0.5% in that range. That means like out of 5,000, we don't even have 20 like in terms of numbers, standards dedicated for them. So that gives a kind of idea that what kind of landscape or scenario we have at this moment for this type of emerging technologies that like helped us to find the gap. Next, I think next is Dreichi. You can go
Yes.
for it.
Yeah. So next is analysis based on process steps and technologies. And what you can see is front-end, back-end fabrications were covered. Also, equipments for back-end and front-end are covered, but somewhat limited. And what is kind of missing, or very few, are for IC design, tools, and blocks. So IC design EDA tool, IC design blocks, IC design whole IC. There are quite few. Next slide, please. And these are analysis based on emerging process technologies, as I mentioned. So from equipment, front-end service, back-end IC design, front-end fabrication, back-end fabrication for energy efficiency and sustainability, advanced resource, chiplet, advanced packaging. What you can see is a few standards for energy efficiency and sustainability. That's one. Also, chiplet and advanced packaging standards very few. And we have to mention that those standards may be obscured in generic process steps. So they are kind of could be hidden in generic process steps. And we feel further studies are needed. But at least these emerging process technologies are not highlighted in the standards. Okay, and then we identified gaps on those emerging device and process technologies. You can start, Sarafuddin, or fast.
Yeah, so as I mentioned, if you remember, but the graph, like there is no like proper global consensus or standards for sub 5 nanometer chips or technologies. Also, if we go for a quantum, be it quantum processor or quantum communication, no de facto like standards specified for interconnects or bus or even the processor architecture, processor, etc. Also no common API data formats for quantum technology for different platforms, because quantum at the moment have many different platforms which are emerging, but there is no concerted effort to standardize them so that people can use in a coherent way. And if you go for neuromorphic, it's kind of similar, no common matrix for neuromorphic performances, and also for design, there are no specific or standard design toolkits, IP cores, or like specified standard tools for testing, both for power and security, etc. So these are kind of like a very significant gap in these emerging technologies. Yeah, Richie, please.
Yeah, also, yeah, as I mentioned, energy efficiency and sustainability are not well developed among all these process steps. And next, we recommend to EU Sarafudin.
Yeah, so as I said, in these emerging technologies, we have this significant gap. So we start to we recommend you to let's say for 5 nanometer logic technologies, integrate standardization into Chip Act, because this will basically support the Chip Act goal you have, and ensure like EU pilot lines to adopt international framework to pull the standard adoption, because this will give a significant boost and strength in terms of standardization to EU. Also for quantum computing or quantum technologies in general, we need to fund or you need to fund in the like ISO, IC, JTC3, and IEEE quantum committees who are like taking initiative at the moment, and there are significant still scope that EU can contribute and take the lead. Also, like establishing the EU quantum standardization roadmap and milestones would be important. And again, as the technologies just getting into like maturity, so promote early EU standards, vocabularies, etc., to like set the standards is very important. For neuromorphic ReRAM AI chips, Richie, you can go ahead with them, or
Yeah, so for neuromorphic ReRAM AI chip, so it's important to tie EU R&D funding to standardization outcomes that we don't see yet. Next is for ReRAM. EU can push JEDEC and SEMI to create specific committees for memory store definitions. Next slide, please. And regarding IC design, it's important to fund, so for EU to fund projects that use and develop open standards in the IC design, and also speed up Chip Act Design Cloud project, and ensure that it includes free OpenEDA tools and at least one open PDK per node to promote open standards. Also place EU expert to IEEE, JEDEC, EU CLE, and there's types or risk V committees. For energy and sustainability, it's important to create common and open rule to recycle semiconductors and chips in EU. Also to fund EU representation in ISO, IEC, and IEEE to start creating committees. Also team up, standards cannot be, pushed by one country or EU. It's important to team up with like-minded countries to push this energy efficiency and sustainability. Next, Karim will explain.
Thank you. Thank you very much. After all those technical aspects, so I will take you through some analysis related to those standards and mainly related to the relevance of those standards. So on this slide, or before diving deep into this slide, so let's look first at the x-axis or the horizontal axis. So we represented there 16 organizations. So we can see we have Accelera System, IEC Automotive, we have SimSenelec, and many others. So actually, through this landscape mapping process, we were surprised by the number of SDOs. So SDOs means Standard Development Organization. And we were surprised by the number of those SDOs involved in semiconductor and chip standardization. We actually identified 75 organizations or committees and subcommittee included. And this number is quite big, actually, when it comes to harmonizing those standards. And this is, we will discuss it a little bit later with our recommendation. So for now, when we look at the graph on itself, so we notice a high number of standards. So the high number of standards were developed mainly by IEEE and IEC. So those are represented with the blue bar over there. So for example, for IEEE, we can almost reach 2,500 standard when we look at the total number of standards. Nevertheless, when we look at the relevance of those standards, we see that they are barely visible, for example, for IEC. So the same with IEEE as well, they are not visible, and many other. So if we remove that blue bar and we look at the graph on itself on the next one, so next slide, so it's a zoomed of the previous slide. So, and we can notice that for those one, we have a big number of standard developed from different levels. So obviously, as highlighted by Ryoshi during the introduction and the methodology, we did classify or use 5 classifications. So we have very high, high, medium, low, and very low. For this graph, we kept only the up 3 levels, so which are very high relevance, and medium relevance. So, for example, when we look at SimSenelec TC47 or IEC, we can notice that they have more very relevant standard developed compared to other organizations. And those are followed after by SEMI, which are working mainly on developing standard for factories and organization building those chips. When it comes to the medium relevance, so those are standard related to agnostic standard, or those could be, for example, related to security encryption or algorithm or any kind of module that could be integrated into a chip, and therefore they are mainly developed by IEC or ISO IEC GTC1. So when we look at other standard organization, for example, when we look at SI2, for example, or JEDEC, we notice that they have as well some high relevant standard, but those from a number perspective that they are not that high, that they are used by many factory or many organization. And so at the end, when we look at this analysis, we can say that some organizations are developing standard for a niche use, and some are developing standard for a broad use by different organizations within the sector. Let's move to the next slide. So when it comes to the gap, so we notice a gap related to those SDOs development. And so this is also related to some SDOs providing high abstract, for example, or they are providing a description related to their standard. It could be the scope. Sometimes they are providing both scope and abstract. And in some cases, we have as well keynotes highlighted in the standard, and some SDOs don't use any of those. And so there is as well a mix of requirement and guidance within the standard. So there is no clear guidance for whoever is going to use and implement those standard from at least a language distinguisher. And this is shows some discrepancy when it comes to the data analysis. Actually, when we did the analysis, it took a little bit of time, and it's not that easy when it comes to such forecast to highlight what will be the future of any standard. So let's move to the recommendation. Next slide, please. So yes, when it comes to the recommendation, so this is where we have obviously the EU and all those SDOs can work together, and they should help create a common and open rule to harmonize standard development, and mainly harmonize the context through the identification or predefined fields, for example. And this could provide, for example, the primary sector or secondary sector impacted by those standards that they are developing. So if we are speaking about automotive, so why not writing automotive as a keynote somewhere in the standard, just after the abstract, for example. And the same, it could be as well highlighted in the document, different other keynotes highlighting to the reader what is the type of standard that we are speaking about. Is it a definition standard? In that case, for example, they can use acronyms for definitions, or if it is a reference architecture, so we can use different acronyms. So obviously, we are interested in regulation and requirement and policy. So those as well are something that can be added in those standards. Some organization might use two terms or different acronyms to highlight some of those acronyms highlighted on this slide. So a lot of work has been done. So obviously by those SDOs, but it will be much more appreciated to try to harmonize and get to a level where all the organization can benefit. When I'm saying organization, is all the stakeholder as user as well of those standard or implementer of those standards. Let's move to the next slide. From my side, I finished, but I would like to highlight as well that we acknowledge the effort and the work done by all the experts, member of this committee. We can see many people as well on this call or on this webinar attending this session. So some of them are member as well of this committee. We can see their name highlighted there. The nice part related to this project is the diversity or the background of each of those experts and where they come from, actually. So we can notice people from Austria, we can have people from Ireland, we have many people from Italy, France, we have people from Norway, Spain, and even South Korea and the US. So it's not limited to the EU. it is well-organized technical working group with a variety of experts with different background who had to contribute to this project. So let's move to the next slide. I think we finished. So thank you very much for your attention, and I will hand over to Ryoshi or Gabriele. Thank you.
Thank you, Karim. Thanks everybody for your contribution to this webinar. So we are moving towards the final part of it. So the question and answers. I've noticed that there were some questions in the box that were already addressed by the speakers, but I just wanted to make sure that Salahuddin or Abi wanted to maybe expand the answer that they provided in the Q&A box. If you think it's relevant to expand the answer that you gave.
Nothing much to add from my side, Gabriel. Just that, yeah, for the question for TC47X, it was definitely part of our analyzed report. So we do have a lot of standards. I think Karim presented the statistics there, right? So StandICT, TC47X, and the IEC TC47. There were maybe, I don't know, 300, 400 plus standards that we did review. Now, of course, nothing is ever perfect. We may have missed one or two here and there. So I'll be very happy to hear from the TC47X people, right? If there's something that's missing or there's something that needs more attention, we are happy to learn from that and keep moving for the next versions of whatever research work we do on this activity. Yeah.
Thanks, Abi. Actually, yes, any feedback and comments on the report, on the work that has been done on the report might be very useful to improve the next version, because I assume that this report won't be a standalone one. There will be other version of it. It is a work which is living and which will be progressing as the time buys. So if we are able also to collect the insights from other experts and increase the number of contributions to the report, that would be absolutely amazing. So I believe that there is a hand raised in the audience from one of the attendees. I'm not sure that, I believe that he hasn't posed a question in the Q&A box, but maybe I can let him unmute himself. Luca Pesando, Huawei France. Luca, can you hear us? You should be able to unmute yourself. Okay, while we wait for the question or comment from Luca, in the meantime, I was curious to delve more into the details of the last section of the report, which is entitled Horizon for SDOs, and maybe I can pose a question to Ryoichi. But also to the other speakers if they want to join. So my question was regarding the sustainability. You placed a lot of emphasis on the existence of few standards addressing energy efficiency and sustainability in general. In the presentation and the slides that you presented, there were some recommendations, especially addressing the EU. I was wondering if you also had some recommendations or suggestions for other stakeholders and actors involved in the process.
Yeah, thanks for your question, Gabriel. So in the report, we suggested to boost, let's say, standardization activity on sustainability by projects, so existing project. And for example, we identified project at IMEC called SSTS, and they're analyzing, proposing a method to reduce energy / CO2 during front-end process. So this kind of project can push, EU to push standards in this sustainability issue. Also, we found that EU-funded project Genesis, also similar topic. So reducing CO2 emissions, also reducing water, also reducing PFAS, also minimizing waste resulting from manufacturing. Those are keep becoming very important. In general, we suggest those projects are the initiator for activities.
Thank you, Ryoji. Actually, I believe that the synergistic efforts of multiple actors could actually contribute to modify the legislative, but also the standardization framework, and so actually make a real change in real world. So actually, in that section of the report, there is quite a lot of emphasis on the intersection between the research and the standardization activities, with some references to existing projects, research projects, even research projects funded by the EU, which contribute or can contribute to the standardization landscape in this industry. I don't know if any of the speakers wants to maybe expand on this.
Mishek, would you like to take on that question?
Yeah, a little bit, but Karim, I like, my biggest thing about this report in general, right, is like as you worked out, Karim, towards the end, right? I think that's what we will have to really look into collaborating. I think that's the key word I would like to use, right? It's not it's easy to say, it's difficult to do. That's what is collaboration about, right? So the key here is to collaborate as much as we can. Right? That is. And it's not easy, like it is known, because when we analyze 5,000 standards, we could see the difficulty in it. It is not easy to analyze so many documents because they're all differently, right? And to solve this problem, of course, we need to change the way we are doing it. Because if we continue to do what we do and expect a different result, say 5 years from now, that's not going to happen, right? If we want to bring in a change, the change has to happen now. And we all have to work together and see what is the best we can actually carry home as part of our work within the standardization groups ourselves. But we are all working with different mindsets. We have different objectives as well, different perspectives and objectives. So I think there is a lot that I've learned. I'll be very honest here. I'm a panelist here, but it doesn't matter. When I was working on this report with all these people here, there was a lot of things actually I learned that I could take back in the groups I work with and see how I can translate some of these asks that you have into something productive. So now this is applicable for many of us, I'd say, because all of us have been working in standardization group with the idea of let's say, improving the transparency, improving the overall interoperability, right? But then at one point, we all hit a roadblock. We say, okay, we have a standard, but how do we use it? Okay, when we start applying this, are we hitting a roadblock? No? So we don't think about all this when we develop it, and we start thinking about it after we develop it and after we use it. You see, so there is a big gap between development and implementation. So that's one thing. Yeah, I would definitely want to take home as a big message to myself and also for the audience here. If you can actually think about these things and come back to us with some feedback, we'll be very, very happy to take it to our respective groups.
Thank you, Abhishek. Since we are almost at the end of our webinar, so Luca was able to write down a comment in the chat, and basically he is referencing to, so the question was related to the possible comments about the risk of a spread of standards and consequent overlaps and lack of clarity in this specific field.
Yeah. It's what we discussed a little bit now, yes. Right? I think that's exactly the problem, right?
Exactly, yeah.
I can add few words there just to highlight that this is what we tried to highlight at the end of this presentation, and showing that we have to collaborate, we have to work all together, but we have as well to improve the way how standards are written. So in the way, if the standard the scope is not clear, if the abstract is not clear, if the language is not clear, if there is some confusion, if it is a requirement or a guidance, so the reader will not be able to understand it. And even other SDOs will not be able to close the gap if there is any gap. And so this is where an overarching authority might be there as well to help guide all those SDOs. And this is where I will pass it to Thomas, because Thomas is from the EU, and therefore he can be the overarching, or at least representing that overarching, to oversee all those aspects. Thomas.
Yeah, thank you. So as you have seen here, this is just the beginning, this kind of analysis, and we're just starting here for the analysis of the different impacts. If you want to participate in standardization, there are some grants from the Commission, and which are giving through the StandICT projects, which giving support for individuals going to standardization or organizations up to 10,000 euros. But also we are looking for, like we said here, to get more inputs about existing standards. Currently, we are analyzing still the data, so we will make public the 5,000 standards in around 6 months, and until then, we're looking still into the things and looking where we have to put on the semiconductor industries our efforts and to develop, I would say, from our side, the CHIPS Act 2.0. So with that, I'm giving it back to the organizer.
Thank you, Thomas. I believe that with these words, we can close the webinar with this call for collaboration and synergy on working on standards. So I want to extend my heartfelt thank to the speakers in this webinar, and also to all the contributors to the report. It was a huge effort, as you have stressed during this presentation, and I would like also to thank all the attendees who actually stayed with us until the end of the webinar. You will find the webinar recording on the StandICT website very soon, along with the slides. Thank you very much for your participation. Have a nice evening. Bye.
Thank you all. Bye.
Bye.
Thank you.
Bye.
Bye-bye.